Fracking, the surprising sustainable comeback. Fracking, the controversial oil and gas technique blamed for earthquakes, water contamination, and environmental damage, majorly developed so that a few Western countries could reduce their dependence on foreign oil. So, what is fracking really? It's a method where you drill deep into the earth and inject high pressure fluid, usually water mixed with sand and chemicals, to fracture underground rocks. These fractures release trapped oil or gas, which is then pumped out. It worked, but it came at a heavy environmental price. Methane leaks, toxic wastewater, and ground instability. The thing is, though, the bigger picture. Even if you manage to brush aside all these concerns, you're still dealing with fossil fuels. But there is another kind of energy deep inside Earth, an almost limitless renewable source. It's called geothermal energy. You see, about 3 kilometers underneath from where you're standing lies a largely untapped source of heat radiating from Earth's core. The US agency in charge of researching advanced energy technologies estimates that, quote, just 0.1% of heat content of Earth could supply humanity's total energy needs for 2 million years. Then, why don't we ever hear about this? Reason? It's geographically concentrated in certain areas. Until a couple years earlier, getting geothermal energy at a scale has mostly meant tapping into places where the heat from these areas leak onto the surface in the form of hot springs. But that's not really efficient. There's huge amount more energy down there. But we can't really harness it because to do that we have to find a natural reservoir. But what if we didn't have to? What if we could make them? You could drill down, inject water, crack the hot rock to let the water pass through, and then collect the heated water and spin the turbines. This is called enhanced geothermal, and a bunch of companies are already working on it. And one among them, Forge. It's a dedicated underground field laboratory. Its goal is to develop, test, and optimize technologies for geothermal systems. In one of the trials, a 9-hour circulation test showed fluid injected in one well came back via another well with outflow water heated to 130 degrees Celsius. One estimate from the DOE suggests that enhanced geothermal energy could enable up to 90 gigawatts of geothermal electricity generating capacity in the US, enough to power the equivalent of 65 million homes. Now, the final question, why enhance geothermal energy? While it does provide us with clean, low carbon energy while minimizing that footprint, it also balances environmental protection, economic feasibility, and energy demand. The LCAs also show that it has very low life cycle of GHG emissions compared to fossil fuels. While and they also provide consistent base load power, unlike solar or wind, suitable for regions with natural geothermal hotspots. Well, I'm not claiming geothermal systems are perfect, but they show how engineering can transform a controversial technology into a clean, reliable source of energy.